Okay, so what I do want to talk about today is using end particles, an introduction to Maya dynamics. We're not going to do end cloth or end mesh yet today, but we will talk about that later on. End particles are far more important, something that we'll use all the time, especially in biomedical animation. And a few people have asked me about this, so we're going to look at doing floaties, sort of like atmospheric floating kind of particles. Today we're going to do instances. So if you want to do something like blood flow, so we need different pieces of geometry instanced onto particles. And we're going to do sticky particles, so how you make particles stick to a surface. And also how to generate a mesh from particles. So I've talked to some of you individually about these things, about with Mansa and looking at the generating a mesh from particles. I was talking to Karine last week about doing floaty particles, so I just wanted to record all these things a little more formally. And then we'll get back onto, well, next week is a holiday, so there's no class next Monday, it's Family Day. But we'll get back onto whatever this, maybe this was scheduled for today, I don't know, but I don't think it was. I think it was rigging or something. Yeah. So when we're working with end particles, the first thing you always have to do is to make sure you're in your preferences on the time slider, you're set to play every frame. That's because normally when we're doing regular animation at real time, Maya can skip frames and allow you to give you as close to a real representation of what your animation will look like at real playback speed. But with any dynamic system, because Maya is tracking the position of particles or points in space over time, it can't skip frames. If it does, the simulation won't work. So you have to make sure you're on play every frame. I'm going to change my settings to 30 frames per second. And Karine showed me last week that if you open scene,
you have to delete the dialog box.
Yeah, open the dialog box.
Sorry, you have to make a new scene.
New scene. Oh, new scene. Oh, cancel. New scene. Look, you can change it here to 30 frames per second. So each new scene that you open will be at 30 frames per second. That's great.
Yeah, it sticks. So from then on, anytime you make a new document, it will be 30 frames per second.
So that's great, which is what we want. So I'll just make sure this is on play every frame. It is. And then if you want to play along with the lecture, you can do that. But we have to give ourselves some space in the timeline. So down here in the range slider, I'm adding, going up to 1,000 frames or whatever, just so there's some time for the simulation to play out. So the first one I'm going to do is make the kind of floaty particles, but this will give us a chance to look at what particles are exactly. And so in our hotbox here, under end particles, I'm just going to tear off the menu. There are lots of different ways to create particles in your scene. Now, when I say particles, I'm always going to be referring to end particles here. You will see in Maya that there's the old particle menu set here, and particles are still available to use in Maya, and they can still be used for lots of things. There are a couple things that you could still use them for, but they won't interact with end particles. And the reason that you want to use end particles is that they are sort of more robust dynamic system. They have some things that old particles don't have, like self-collision. So with new particles, end particles, they can bounce off each other. They can strike each other, as well as striking collision objects in the scene. The old particles can't do that. So when I say particles, I mean end particles. So you can create end particles in a number of different ways. We saw a little bit before we filled an object with them. You can emit from an object. You can create an emitter. So an emitter is just a point in space that shoots particles out. And then you can just sort of paint particles in your scene. If you just need a couple of specific particles to do things, you can do that. Most of the time, we're going to create an emitter. Sometimes filling an object is useful. But for this floaty particle one, we're going to create an emitter. I'm going to open up the, and like I say, I'm recording this, so I'll post this on the website after we're done. I'm going to create an emitter, open up the emitter options. So when you open up any of these things, this one, I'll give it a name. The solver that it's going to use in the end dynamics, the solver is the nucleus node. So this one will create a new solver because there's no nucleus node in the scene yet, and we'll see that in a minute. There are different emitter types. The omni emitter is like a point in space that will shoot particles in all directions. Directional, you can choose what direction it shoots in and what spread, so it's more like a cannon. And then there's a volume emitter, so you select a shape, and then that shape will be filled with particles. So for the floaty particles, in something like this, we have a scene that we've created, we have objects in the scene, and so we want to fill a volume of space with particles that can sort of swish around. So we're going to create a volume emitter. Down here you can choose the volume shape. I'm going to just choose a cube. And then you might have some other settings down here. Your away from center might be set to 1. I just want all these speed settings to be set to 0. So speed, away from center, along axis, around axis. There are some instances where you do want these things. You want the particles to be born and start to move. But in this case, we want them just to be born and sit in their space, their place. So I'm going to create this. So we have a little cube here. And so this is the emitter. I'm just going to open the outliner so we can see what's being created here. So what have we created? The floaty gen here, this is the emitter. The particle, end particle is the particle shape itself. And the nucleus node is the solver, or the thing that defines the physical environment in which the particles exist. Just going to open up a couple of things here. I want my time slider and my check. So if I just play this animation now, the particles are born and then they immediately fall. So you can see they're going on down forever into space. And they'll just go on and on and on until your computer gives up. But in this case, we don't want them to fall. We just want them to be born and then to stop. So I'm going to select the particles. And so there's a lot of stuff to go over for the particles. I'm going to stick to a few things, and there are a few things you come back to all the time. So even though there's a lot of stuff in this attribute editor to learn about, there are just a few things to get started that you need to know. So one of the most important things here, if we ignore everything else, is the dynamic properties. This is where you do a lot of your work. Ouch. So if we just twirl that down, the first thing I can set here is ignore the solver gravity. So what is the solver? Remember, the solver is the nucleus node. So let's just jump over there for a second. So up here we've got the particle shape, the floaty generator, which is the emitter, and then the nucleus node. So the nucleus node sets things like gravity, which is at 9.8 in the negative y direction. So 9.8 acceleration meters, what is it, meters cubed, negative y. The air density, wind speed, things like that. So you can do interesting things with end dynamics. You can create something like a helicopter that can actually work if you spin the blades around, because you have things like air density and lift and things like that. So you could make something that actually works, but it would work differently if you had a different air density here, the kind of resistance and pressure and things like that. So for us, the only thing we really have to worry about now is gravity. I could turn it off here if I wanted to, but I might have another particle system in the scene where I want gravity to work, but not in another. So I'm just going to leave it on for now. We've got other things like solver attributes, and we'll come back to this a little later on, substeps, collision iterations, and this is just how many times, this all has to do with how many times Maya checks on the particles, like where are they. So you can imagine if there's a particle floating and there's a collision object here, Maya checks its position right here on one frame, and then if it doesn't check it until the next frame, it might have time to pass through the collision object. But if it checks on subframes, like 10 times per frame, then it's going to check it before it gets through, and it will document that collision and it will bounce off. So sometimes if you turn up collision iterations, it solves things like that. But anyway, we'll talk about that stuff later. But these are all sort of quality settings that you can change. So if we go back to the particle shape, which is, like I say, where we do most of our work, we're just going to turn on ignore solver gravity here. So I'll just go back to the beginning, play the animation, and now you can see they're not falling. And they're just filling up this space. Now I can't remember what kind of particles I created. If I just look in my menus here again under particles, create particles, you can see that, let's tear this, oh I think I already have it turned off. Before you do any of these creation options, you can set one of these presets, points, balls, cloud, thick cloud, and water. This one I think is the default, or maybe cloud is the default, but having balls turned on means they'll collide with each other. So if that wasn't the way you set it up, we'll set it up. We can go in and change things so it works. But these things should be bumping into each other as they're created. But there's nothing limiting how many of them are created at this point. And I do want to limit that. I don't want an endless number of particles. So here back in the particle shape node, I can check in under count how many there are. And currently there are just more than 1,100, which is too much for what we need. We just want some particles floating around here. So I can't change the count here. You can see it's in this kind of blue color. That means the information is coming from somewhere else, and I can't change it. Anytime your attribute field is a different color, it means it's receiving information from some other action, either from an expression, a connection, a keyframe, a constraint, or something like that. But if we just go down here to emission attributes, so this is another thing. There's not much to learn in here other than the emission attributes has a max count. -1 means infinity. And we can change this to amount that we want the emitter to stop at. Change that to 100 and rewind. So you can see now it stops when it reaches 100. So there are other ways you can make it stop too. You could keyframe the emitter. So the emitter has a rate. If we just go in here, it's got a rate per second. So it's got 100 particles per second right now. So in this case, after 30 frames, all my particles should be generated. I could keyframe this on, after 1 second, keyframe this to 0. And that would stop the emission of particles too. When I do it this way, the max count, if some of these particles were to die, then the emitter would replace them, would bring in some new ones. So you can set the lifespan for these particles, and you may want to keep a consistent amount. So using this way, would allow you to do that. If you keyframe the emitter itself, then it would no longer ever create any more particles until you keyframed it to do that again. But for what we need, this is just an easy way to do it. Max count to 100. Okay. But now you can see that every time I rewind, it has to reestablish this initial state, or it has to play through the animation again to get my particles up here. But if this is the way I want it, to fill my space with floaty particles, I can set this as the initial state for the particles. And in the menu set here, it's under End Solver. I'm just going to tear that off. So here you can choose which solver is associated with these particles. It's already associated with the nucleus 1 node. Now this is something you have to be careful of if you're referencing files in. It's better if you can keep everything under the same nucleus node. So if you're referencing files in that have nucleus nodes in them, you're going to get stacks of nucleus nodes. So you might have to arrange things a little differently or reassign them to new solvers here. But the initial state here is what we're interested in, and we just want to set it from current. So whatever they look like now, this is what we want it to be like on frame 1. You can clear that initial state down here afterwards if you're not happy. And I'll set from current. Now when I rewind back to frame 1, you can see that they're still there. They don't disappear. And now if I play the animation, oh, sorry, you can't see my time slider. Let me just move this up a little bit. Oops, wrong button. Okay, so I'm playing the animation and there's no change. That's because there's no forces acting on these particles to make them do anything, because they were created with no speed, so there's nothing pushing them, and there's no force in the world to make them do anything. So that's what we're going to do now. We're going to add a field into the world to make them move around a little bit. And then we'll look at some of the attributes of these particles and how we can change their behavior a bit. So if we want to create a field that will move the particles around or do something to them, that's also down here at the bottom of the hotbox, fields. I'm just going to tear this off so we can look at these. Now I'd invite you to play around with these a little bit, but there are different things. Air is something like making a fan or wind that can blow the particles in a direction, so it's a directional field. But there's also one in there called wake. And that's an interesting one. So you imagine if you have a boat moving through sort of a pile of particles that are acting like a liquid, the wake can make them so like a wake in a boat or behind water skis or something like that. So you can attach a field to a piece of geometry so as it moves through something or somebody's foot that can maybe make puffs of dust come up when it gets near the particles, that sort of thing. Drag is a useful one because let's say you've got blood flowing or something and you want some area where the particles slow down. You can put a drag field in that area, and when they enter it, they'll drag. It will be more air resistant, so they'll stop moving as quickly until they exit the field. Gravity is a way to set different gravities for individual particle systems. Newton is something. Radial is a way to push particles out from a central point. But you can also reverse the magnitude to make them sort of suck into a central point, like a gravity onto a point, which is useful if you need to keep a bunch of particles together, like a bunch of bumblebees or something like that. You can have them moving around, but if there's a radial field inside where they are, they'll all try and stay inside that area and sort of bounce around to make that happen. So the radial field is quite useful. Turbulence is what we're going to use in a minute. Uniform is like gravity, but without acceleration. Just pushes them, keeps them at a uniform state. Vortex is like a tornado kind of thing. And then these ones we'll talk about later, volume axis and volume curve. These are ways you can make particles move along curves and things like that. Okay? So there's a lot to play around with in here, and with particles the best way to learn about them is just try them out. But we're going to work with a turbulence field right now to get these things moving. So I'm going to open up the option box here for the turbulence field, and I'll call this mixer or something. And then you've got a bunch of different settings here. Actually, let me just reset. I don't know. So you've got a magnitude, which is the overall strength of the field. Attenuation, which is the fall off of the field. And the frequency is, you imagine if there's a sine wave, you know, it kind of goes like this. Greater frequency, there'll be more troughs and peaks. So in a noisy kind of turbulence like this, it'll be a much more granular, shaky kind of turbulence with more frequency. With less frequency, it'll be kind of broader motions. Right? Phase X, Y, and Z is a way to sort of make a bias in the motion, whether it's up, to the side, to the front, using one of those. And then noise level just adds more randomness in here. So I'm going to create a volume shape that will be the area in space where this this turbulence field exists, and I'll create another cube. So now I'll just scale this up so it encompasses all of our particles in the system here. I'm just going to turn off my grid. And then you can play the animation. And now you can see they're moving. So the turbulence field is forcing them to move around. But now they're escaping. They're kind of getting away from the area that I want to have these floaty particles. So how can we keep them in here? The easiest way to do it in this situation, since we have a defined space that our field is in, this cube, if we look at the attributes of the field here, and I'm going to use the channel box because everything is included in here that we need. So you can see that we still have the magnitude settings here, so it's at 5. So if you turn this up, it'll be stronger. Lower, it'll be less. Attenuation, I don't want any fall off, so I'm just going to turn that to 0. So max distance. Now these things don't make as much sense when you have a volume of a field, because everything occurs within the volume. You can have a field that's not a volume, it's just a point in space, and then attenuation and the max distance makes more sense, because if you have a point in space and around that you've got the field in effect, the max distance, if it's set to 10, beyond that you won't feel the effects of it, and the attenuation is the fall off in strength from the center point to that 10 units away. So right now it's set to -1 because that means infinity, so the max distance goes on forever. It actually just occurs inside here. But you can see here there's a thing called trap inside. And this is on the turbulence node. So I can turn this to 1. 1 means on, 0 means off. And I can play the animation, and now you can see they try and stay inside. And they're bouncing off each other. So for a kind of floaty particle effect, this is not really what we want. It's too active, too much movement and bouncing around. So we can start to change some of these settings in the field, and then we can also look at it in the particle. So I can first turn the magnitude down to 1 or something. Now you can see they don't move quite as quickly, but still, to me, that's too much movement. I could even turn it down lower if I wanted to, the magnitude. So that's pretty good. They're just moving very slightly. But let's turn it back up to 1, and then we'll try and change some things in the particle setting itself. I might want to turn up the frequency to make this feel a little noisier. It's kind of hard to tell what the difference is. And we can also add noise here if we want to. It's kind of hard to see with this low magnitude any sort of change. That's because I have it selected. Oops. Just because oh. There we go. Thank you. So how else can we change these particles? Well, we can change the world they live in, which is changing the field or the nucleus node, or we can change the particles' qualities themselves. So here I'm going to open the attribute editor so the settings are easier to see. And so there are two main ways to control particles. One is through this dynamic properties menu set and some of the other things, their size, their lifespan, and things like that. But there's also writing expressions on a per particle attribute. So whenever you hear PP in talking about particles, that's a per particle attribute. So you can control things based on different qualities a particle has. When it was born, when it collides with something, you can make it change or do something, have a new behavior. But let's first look in just in the preset dynamic properties. Got dynamics weight. This is simply setting how much it listens to the dynamic properties of the world. Conserve has to do with inertia. So if you have this turned down a little bit, it will lose, the particles will lose their energy over time. With conserve set to 1, they don't. So if we want to slow these particles down, we can turn conserve down to 0.5, let's say, and this will probably slow them down quite a bit. Yeah, so now you can see they're just barely moving now. But that might not be bad for a floaty particle kind of thing. But you have to remember that that was actually 10 seconds of animation what I just played there, because we were on play every frame. So it might look like it's moving really slowly, but it actually might be moving really slowly. Because it took 10 seconds to, that would be 10 seconds of rendered frames. So you have to look at that and try those different things. So I could turn, could sort of back up a little bit, say to 0.75. And so we've got a little more motion, but they still are losing their energy. So I'm going to turn conserve back all the way up to 1. So what I recommend when you're working with almost anything in Maya, but particularly when you're doing dynamic tests like this, just change one setting at a time. Test it and see what effect that makes. If you change 3 things, then you can't tell what's making that happen. So we can turn up drag, for example. That is something that will potentially slow down the particles. I'm going to turn the magnitude back up a little bit on the turbulence just so we can see the changes more easily. So I'm going back up to 5 here. So that's actually not kind of interesting here. If we look at this kind of red particle here, you can kind of see the noise a little bit in the turbulence, the way it's, and the small frequency, the way it's being pushed around in these small cycles. You can see some of them aren't moving at all. So this drag might be too strong. But you can see that they're bumping into each other too, so they're interacting with each other. See some bumps going on there. This one's not moving at all. Oh, it's moving a tiny bit. Might be just because we're looking at it in that way. Sometimes they can get stuck on the walls too, a little bit, if they're being pushed out. So you can always, if you find that's happening, you can make a very soft radial field that can push them back in a little bit, try and force them in. So that's kind of an interesting. It's still a very active turbulence. For a floatie, I would probably turn that down. I would turn the frequency down a little bit. It really depends on the character of the animation that you want. So I turned the drag off there. So I think, did I? Oh, it's back to 0.1. You can also use damp. Damp is another way of just reducing the effect. They're just less likely to move. So they're just very sluggish, sort of. So these are moving really slowly because this is almost 10 seconds of animation and they've barely moved at all. So this is something you'd really want to play blast out too. You know, play blast this out to see what the real animation is like. You also change their mass. By default, the mass is 1, but if you turn the mass up, they'll act differently, gravity and things like that. So, but we can just leave that for now. It's not going to make a big difference. So like I said, these things are bumping into each other, but we might not want that if it's a sort of floaty thing. We might not want to see things come together and go boink and then move away from each other. So in the end particle settings here, just above dynamic properties are collisions. So I'll close dynamic properties for now and open up collisions. So by default, I think all particles will have collide turned on, and that means they can collide with objects outside of themselves that you set as collision objects. Self-collide means one particle within this particle shape can collide with another one within the particle shape. Collide strength, 1 is, it's a multiplier, so if you turn it down, it's going to multiply by 0.5 or whatever. Collision layer we'll talk about later. This is how you can set things on different hierarchy of what can bump into with what. But for now, let's not worry about it too much. Then we've got collide width scale and self-collide width scale. So when a collide width scale is set to 1, then it's the size of the particle. So it's the size of the particle. It'll bump with other particles on that edge, or with other objects, I should say. And then the self-collide width scale is a multiplier of that. So it's also set to 1. So the collide size of this is the size of the particle that you see here. But you can change that if you want things to be able to overlap slightly when they hit each other. Then I can turn the collide width scale down a little bit, 0.75. So, you know, a quarter of the diameter of one can overlap with a quarter of the diameter of its neighbor, so you'll get softer, or not softer collisions, but some interpenetration, that sort of thing. If we want to see what this looks like, you can see there's a thing called solver display here. It's turned off by default. If I turn it on, we can see the collision thickness, and it shows it in yellow here. So that's the size, and it's the same size as the particle. Or we can look at self-collision thickness. Now we can't see because it's actually inside the particle. If I go into 4 mode, whoop, then you can see the collision size is there inside the particle. If I turn it up to be a little bit higher than the size, 1.25, for example, and go into 5 mode, then you can see the collision envelope is actually bigger than the particle. So this is, when we talk about instancing geometry later, if we have a piece of geometry that's bigger than the particle, we might want to turn up its self-collide size to encompass that a little bit. You can set bounciness, so how much energy will be retained when it hits something. If it's 0.9, you can see it's going to lose some of its energy. It's not going to, if it's set to 1, it'll bounce off and move. Friction is similar, except it's on a tangential drag, so when something rubs up against something else, that's where friction will come into play, or take away some of its energy. And stickiness is the likelihood it will stay stuck to it. Now, this doesn't always work, so if I turn stickiness up, then we might see some of these particles. Turn the magnitude. Turbulence up a bit. I must have my drag still turned up here. I can't remember which way my mouse is going. Oh yeah, my damp is turned up. So you can see that some of them starting to clump together, like around here. So stickiness is making that happen. But that could be an interesting effect if you want, see down there, little clumps forming. You know, if you want things to seem like a random motion, but if things strike each other, you know, some sort of reaction is happening. And you could do stuff, probably, like if you wanted to set blue particles to stick to other blue particles, you could write an expression. Like if RGB per particle equals RGB 001, then stickiness equals this. So you can make the blue particles sticky and the red particles not sticky, for example, if you wanted to simulate some sort of chemical interaction or something like that. So I'm just going to turn stickiness back down to 0. So now they're moving around like crazy. So I turned my magnitude way up. You guys okay? I know, Monday morning, yeah?
If you have the stickiness set to a certain value, if it's like a low value, do things sometimes stick but then fall apart as well?
Yeah, I think it's like, there are other settings in Maya. There's another one called glue strength. So it's the amount that stick together unless another force pulls them apart. So yeah, if it's a higher amount, you'll need more force to make them come apart later on. And you can, and this stickiness is not just about one particle sticking to another. If there's another collision object in the scene, like a piece of geometry, then it can stick to that too. Okay. So, where are we? We got them moving. They're moving too fast for me, so let me just fix that again. I'm going to turn my damp down. Or turn it up, sorry. So just moving a little bit. Now, obviously, if we're making floaty particles, we don't want these big red and blue spheres floating around. We want something else to render. Generally, something sort of more amorphous or sort of ethereal looking. So we can render these in different ways. So let's close dynamic properties. Count collisions. There's particle size here, so you can turn up the radius, the particles, but you can see it's acting on a global level. We'll look at changing their size individually later on. Oops. But we also want to look at shading, right? So how the particles render. So if we look down here a little farther, there's the shading menu set. We can open this up. And the particle render type here is blobby surface. I'm just going to save this file in case Maya crashes. Sorry, excuse me for a second. I'm trying to organize my new computer in a thoughtful way, so I can find things in the future. So I'll call this oops. Okay. So the blobby surface, you can see it says SW beside here. That means it can be software rendered, which means you can use the Maya software renderer to render them. So if I open up my render window here with the Maya software renderer turned on, I can render these out that way. You can also render these with mental ray. Mental ray is gone away, so just to turn that on again. This takes a little longer with mental ray because there are reflections on here, so I think so it's trying to calculate the reflections. But we might not want these sort of spherical shapes. The thing that blobby surfaces can do is they can sort of metaball with each other. So if we open up the attributes here and go under shading, blobby surfaces, we can turn up the threshold, which means it's a threshold for how close they have to get before they overlap with each other and form a kind of metaball where the two things merge together. Has to do with the particle size too, so if I turn that way up and do a render here, let's see if it works. You can see how they're starting to merge in these areas, so you can make a blobby surface. It's called a blobby surface. There are other render types here: blobby surface, software render, cloud, software render. It makes sort of a little soft cloud looking thing. So that can be useful. Tube. What are tubes? I don't know. I never used tubes. Looks like clouds too, but I think when they're moving, they leave a bit of a trail behind, so they look more like tubes. But like I say, for a floaty particle, we might want to have something that's a little more indistinct, right? And here we can use some of the non-software rendering ones. You've got streaks, sprites we'll talk about in a minute, spheres, so just they render like little pieces of geometry. So the software renderer can't render these. It doesn't have a little SW beside it. But mental ray can, I think. Mental ray, can you? Yes, okay. So you can use mental ray to render any of these other types of particle types. Then we've got things like points, and these just make tiny points in space. Make them a little bit bigger, like squares. They render like circles. They look like squares, but they render like circles. But you know, you could use this to render just and blur them out in After Effects and turn their transparency way down. You can render them like that if you wanted to. There's another one called multi-point, which is taking each one of those particles and making a little cluster of dots around it. So it looks similar, but it's a cluster. You make something like that. I made my point size quite big. Let me just turn down the point size a little bit. So I can make them smaller. I can turn up the number of points in each cluster and how big the cluster is. So if you want to do a cheaper sort of space filling, you can make multi-points with lots of points within it with a larger radius. And then they move around, but they still, each little cluster acts like a single particle though. But it's a way to fill the space a little bit more. Like this. Or we can choose to pull in the radius to make a tighter cluster and maybe reduce the multi-count a little bit to make these little bundles of things. And when you render them out and blur them in After Effects a little bit, then you'll get little sort of more randomly shaped little clusters. Okay, so let's leave it like this for our floaties. just kind of random shapes. Now we have to figure out how to change the color here. Everything is kind of red and blue. That's also under shading here. They've got an opacity. These are set to fully opaque. And then we've got a color setting down here in the shading. And it goes anywhere from red to blue, and it's based on a randomized ID. So when each particle is born, it has a number, just like in a totalitarian state of particles. So we can look at these if we go to numeric, and the particle ID is here, and you can see each one has a number. So 34, 43. So it's going to randomly choose what color on that scale to give each one. So let's say I just want them all to be the same color. I can just get rid of that, change this to white. I'll just make a whole bunch of white floaties, because we'll composite them in After Effects later on. But you can change the color they get based on their age, amount of frames since they were born, their speed, their particle ID, randomized ID, radius, things like that. These are all the built-in ones. You can write expressions to control each of these things too, but we can just set it to constant so they all get the same color. But there's only one color to choose from anyway. So incandescence, yada yada yada. So just going to go for a few minutes longer before we take a break. But I want to talk about how to render these things out. So you can see we've got a nice volume of particles that are moving around in a way that we like. So how do we render these things? Well, we can render them just like we would render anything else, using the mental ray renderer. You know, putting them on their own render layer if you want, doing them built into another render. Or we can use a whole different rendering option in Maya called the hardware render buffer. So I'm just going to create a camera here. And we'll look through this camera. Let me get rid of this. So just like any other camera, when we're setting up a shot, we have to set the resolution gate. So let's say it's something like this. So, you know, get nice little floaties moving around. And so if we were to render this, of course, just like normal, you can set the mental ray renderer, the number of frames, the camera that you're shooting from, all that stuff that you guys have recently done. Change the quality, all that kind of stuff. And this is a good way to do it. But there's another way to do it that's less expensive in terms of render time, called the hardware render buffer. So in the, you can't see it up here, but I'm in the window editor. Under rendering editors here, there's the hardware render buffer. And this is a renderer that uses your graphics card to do the rendering rather than calculating through the CPU. So you know on your computer you've got your CPU, your central processing unit, and you've got 8 cores on each machine, so you've got 8 cores to chug through the animation to render. But you also have a graphics card. On these machines, they're a little bit old, but for something like this, they're perfectly suitable, and it's got its own processor and its own dedicated memory. And it can use this to render the shot. And essentially, it's taking screenshots of a selective region. But it renders really fast for this sort of thing. So we choose the camera that we want, shot cam. And then setting up the renders is totally different than setting it up anywhere else. So here in the hardware render buffer window, which, just as a reminder, is under Window, Rendering Editors, Hardware Render Buffer. You can open up the attributes for the render attributes here. And it's similar to your other render attributes window or your render settings, but it's different enough to be annoying. So we can give it a file name, mark particles. The extension, how you want it to be named. So we want name, number, extension. You can see the frame padding is built in here. Start frame, end frame, by frame, image format, normal stuff. And then the resolution. By default, it's like this ancient resolution that nobody ever uses anymore, NTSC 4D. And this is the X and Y pixels. No. Yeah, X and Y pixels. And here's the pixel. The pickle aspect ratio. Like this one, with warts. So we can choose HD 720. And you can see the aspect ratio is here, 1.77. Divide one by the other, you get 1.77. And then we always just use 72 ppi. I don't know if there's any 96 ppi, no. But there are, I mean, this is kind of changing now. Screen pixel densities are changing with things like retina displays and stuff like that. But for now, just stick to 72. Okay. And alpha source here, we want to change this to either hardware alpha or luminance. We just leave it on hardware alpha. Some video cards don't deal well with this, but I think ours are fine. Texturing, yeah, we can do full image resolution. So the reason that we sometimes want to click this on is if we're rendering out an HD image, but your computer screen, like for example, my screen right now is at 1440 by 900. If I want to render an HD image, it's actually bigger than my screen. And so doing a screen capture won't work. So if you turn on full image resolution, it kind of does it in phases. You don't see it, but it will do the whole size. And then we've got multipass render options here, which is important for doing these particles because it will do, on each frame, it will check the position of the particle a number of times on each frame and it will blur the results. It will only render one final for each frame, but it will kind of blur the results. So we can turn up the render passes to whatever, 9, and try. And if I just click here, the little clapboard, this is in the render buffer view. If I just click here, well, it's interesting. It gives you a weird screenshot. I'm going to turn off full image resolution. Okay, yeah, it's good, eh? So there, take that in After Effects, you're done. Now, so let's just try actually render a sequence because I think it should work. So if we do a render sequence here, so this is how we launch. This is like doing a batch render. See, it's flashing. I think this might be because I've got the projector on, causing problems. So it's running through. We've just got 20 frames left to go. Now let's see if it actually works. So there's a thing up here called Flipbook. So we can open. Now this doesn't always work either. We might have to open this up in After Effects. We can open up marked particles. Let's see. It's trying to open up FCheck. Oh yeah, there they are. So you can see they're just moving around. So FCheck is an image viewer that comes with, it's a frame checker, comes bundled with Maya. I've noticed on the Mac it doesn't always work perfectly. It's working here now. Right now it's playing every frame, E, so if we click that off, we can get a better idea. This is like real time versus play every frame, so now we can get a better idea of what the renders look like. So that's pretty good for floaties. You can invert the image, so you can see it a little better. You can do lots of different things here. You can change the saturation. If there's a Z depth pass, you can check it here. You can look at the R, G, and B, but we don't really need to see all that stuff. So this worked well, and it takes very little time to render. And then you can bring this directly into After Effects. So fcheck is something you can use for any of your animation sequences. So if you render out 100 frames of something or 1,000 frames, you can load this up through fcheck if you can import or open a sequence. Here, so let me just see if it's working in the Mac version now. Yeah, so this is actually a really good way, and it's less expensive to use than in terms of time than bringing it into After Effects. So you can just check the speed of your animation, what the renders look like, and stuff like that. The Windows version of fcheck, you can right mouse button and draw on the screen. So if there are images you want somebody to change, you can circle part of the frame and say, you know, that little strand of DNA's got to go, and that kind of thing. Okay, so do you guys have any? Do you want me to go over anything else from that again? I want to take a break in a few minutes and come back to After Effects and bring this stuff into After Effects. But did you have any questions about anything? Yeah.
Can you assign a shape, like if you already have like a little model of like a molecule or something? Can you make that into the particle?
Yeah, we can. Let me just do that quickly because we're going to come back to this later. But it's quite easy to do. So, although there's a bug in Maya 2014, which is going to require you to use Maya 2013 to render out these shots. But let me just show you how to do it. So let's say we have a polygon object like a torus, the good old torus. I'm just going to make it a little smaller, change its settings slightly so it's a little skinnier. So let's say that's the geometry we want to place on each particle. So this is called particle instancing or instance replacement. So I'm going to delete the history on this object. And then with it still selected, or we can select it afterwards, there's a menu here under End Particles called Instancer bracket Replacement. So if I open it up, you can see that my p-torus is already there because I had it selected when I created this. And since I only have one particle shape in my scene, it selected that particle to attach it to. If there was more than one particle shape, there would be a list here of these. The thing to notice here for the next example we're going to do a little later on is that each object that you place in here has a number. And this is called its index. And so this index number for this one is 0. Indices always start at 0 and then go up. But we'll get to that in a minute. So we just say create, then it instances that particle to each of, or that geometry to each of these particles. Now in this case we wouldn't necessarily want to see those multi-points. So if you want to just not see the particle but only the instance associated with it, you can either turn it to points or turn it to numeric in that shading section here, because numeric won't render. Points will render actually, so the only way to get rid of it is turn it to numeric. You can see the particle numbers. The other way to do it, down here at the bottom of the particle shape, under Object Display, if you click on this thing called Intermediate Object, then you're telling Maya essentially that you're not creating these particles for rendering, they're the intermediate object to hold something else, and so don't render them. So now, when we play the animation, these things move around. Now one thing that probably many times this year you're going to long for the days of Cinema 4D. It's like, Cinema 4D does this so easily. Why is it so hard in Maya? I'm sure you say that all the time. One thing that Cinema 4D does that I wish Maya did is that these instances can't collide with each other. So the geometry doesn't actually bump into each other. It's still that invisible particle that bumps into each other. So it's always a spherical collision. It's never the shape of the geometry. So if I wanted to make sure these didn't bump into each other, I'd have to make the particle big enough to encompass the whole thing, or that self-collide scale to be big enough. But then it's going to be, this big because it's spherical, so there's going to be a region around there where they don't collide.
There's no way around it.
There's no way around it in here. There's a thing in Maya called bullet physics, where you can combine soft bodies and collision bodies with particles. But it's pretty new, and I haven't used it that much, but we can look into it. But this is normally how you do most of this stuff. And unfortunately, it doesn't do that one thing that Cinema 4D does so nicely.
Can you randomize their rotation?
So if you want to randomize the rotation, next thing in my talk, thank you very much, you can do that. So we'll do this and then we'll take a break, because this introduces the idea of a per particle attribute. So just to avoid confusion, let's close down these menus that we're not using here in the particle size, object display. So we looked at all these things. Now, down here below shading is the per particle array attributes. And this is how we can control these things on a per particle basis. So if I want some of them to be rotated this way, some to be rotated this way, this way, we'll randomize it. We can't tell the whole group to do one thing. We have to tell each individual particle what to do. So there are a bunch of built-in per particle arrays. So, for example, the position. If you needed to know the position of each particle, you could ask that question in here. You could ask Maya to record the position, take that information, and use it for something else. And this afternoon, I'm going to have you walk through a tutorial on the wiki where you have to do exactly that. Mass, acceleration, lifespan pp, which is important, we'll look at later. But there's nothing for rotation built in, so we can create our own. So there's add dynamic attributes right here below it. So we can just click on this general button here, and it will open up this menu set, this option here. So we can create a new per particle array, or we can click on this tab up here that says particle, and we can look and see if there's a rotation pp already. There is a rotation pp, but we're just going to make our own anyway, because it doesn't matter. Because this is just still an empty set. It's an empty attribute with no value. So let's create our own. We'll call it something slightly different. We'll call it rot pp. And this is going to be a per particle array. And you can either set it to a vector or a float. So a float value is something that has a decimal point. It's not an integer, it's not a whole number. It can be 1.78453, blah, blah, blah. A vector is something that has three values, RGB, XYZ, and so on. So in this case, a vector could work, because then we could control its rotation on X, Y, and Z separately. But in this case, I don't really care. I'm going to just randomize it. So if I use a float, then Maya will just use the same value for all X, Y, and Z. So I'll just use a float for now. Unless it doesn't work, then I'll come back and change it. I can't remember. Okay, so we will say OK. And you can see now in the per particle array attributes, the rot pp, rotation pp, has its own field. If it ever doesn't show up when you do that, just click away from the particle and select it again, and it will appear. But I can't select it now because I turned it into an intermediate object, so I have to select it through the outliner. So you've got these fields here, and you can see some of them have writing in them. If you click on here, you can start to type, but nothing will happen. You can't type directly in these fields. It's kind of a bad user interface design, but you have to right-click on here, and this brings you into another menu. So we're just going to do a creation expression. So I did that under rot pp, but it actually doesn't matter which one of these I click in because these creation expressions are all housed together anyway. So we got, if you look here, this is our expression editor. You can create creation expressions and runtime expressions. So a creation expression is run only once when the particle is born and it executes this action. A runtime expression will be executed on every frame. It will be checked. Like, should I do something? Should I do something? Should I do something? But here we just want to change its rotation once when they're born. So we can say rot pp equals, and then rand 360. So when you type the rand command, it can be anything like rand between 0 and 10. That will be randomized any value between 0 and 10, not including 0 or 10. So it can go down really low, but it'll never get to 0. It can go really high, it can 999.999, whatever. But it'll never get to 10. If you want to include 10, you have to go to 11 or 10.1 or something like that. Anyway, it doesn't matter. But if it's between 0 and something, you can just type the final number. So rand 360. It'll just randomize between 0 and 360. And we're acting on degrees here, so that's why we've got 360. And I just end it with a semicolon. Every line, every completed command, you end with a semicolon. We'll talk more about expressions later on, but we'll do little bits of expressions here with particles. If you ever want to look at all these different mel commands, in the help menu, there's my help, but there's also the mel command reference here. And you can open that up, and it will open in a browser, and you can see that Maya's windows never get out of the way. So you can take a look at all these different commands. So here's rand. And it's, until you start using them, it just seems like a whole bunch of nonsense. But all of the documentation is here and gives you some examples of how it can be used. Oh, so I actually don't have to put it in brackets, but it will still work in brackets. So now, once you type an expression, you have to hit create at the bottom of the expression editor. And you just want to keep an eye on your status line down here. Sorry, it's hard to see, but right down the bottom where it gives you results, if it turns red, it means there's a syntax error or you've called a bad command or something. So now when I rewind and play the animation, nothing happens. So we set a variable and we gave it a value, but we haven't told Maya what to do with it yet. We just called it rotation pp or rot pp, but Maya doesn't know what that means. Maya's your dumb friend. It only follows instructions. So if have you ever read the story called Silly Saburo? You're all familiar with Japanese fairy tales, right? No, okay, anyway. So there's one called Silly Saburo, and he only follows instructions literally. And that's what mine is like. I'll bring it in and read it to you one day. Where's my... I can see your Monday morning faces. Don't worry, I'm going to take a break in a second. I'm just going to finish this one part. So we made that expression. And then below the per particle array attributes, there's a thing called instancer geometry replacement. This is where we can set a whole bunch of things about the scale, visibility, object index. And then we've got rotation here. So if we go down and we try and find rot pp, it's not there. But up here, if we just click on allow all data types, then it will find all of our preset, the little ones that we write. There's rot pp. We click on it. And this is where I have to experiment because I can never remember which one we have to set it in. Okay, maybe it's not rotation. Rotation type? Nope. Aim direction? Nope. Up the aim axis. This has got to be it, right? No. I can never remember. I'm just going to set them all. You're making me angry, Maya.
Yeah, do you, because you set your solver to the user state, is it because you didn't get back to that point?
Yeah, so maybe you have to reset it so they don't have a creation time now. That's true, I forgot about that. So let's select the particles and go to EndSolver, initial state, and clear initial state. Nope, still no dice. Ah, okay, so to replay. Yes, good point, thank you. So because it's creation expression, they were no longer being born because they already existed in the world, so I had to reset their initial state and replay the animation for that to be felt. So it is through, I'm pretty sure it's rotation where you set it, rot.pp, and then you'll get a random rotation on the initial state of the particles. So when it gets to this point, now we can reset their initial state. And we go back to frame 1, and things are all good. Okay, so we tackled a whole bunch of stuff in there. So what I'd like to do now is take a break, but when we come back, we actually got into the second piece that we're going to talk about, which are instances. So I'd like to talk about sticky particles and then bringing them into After Effects, some things you want to consider for rendering. So any last questions before we take a break for 10 minutes? No?
If you have individual animation for the instance, they should work as well, right?
No. If you have animation on the instance, the way usually you do it is, let's say you wanted that torus bending like this, then you would have 5 copies of the torus in different states of that animation, and then it would select, on each frame it would switch to the next. Actually, it might work. Actually, I say that.
Like if you have a bacteria, which is...
Actually, hold on, yeah. Let me just put it, sorry, I thought you were having a break, eh? Wow, Andrew ruined it. I'm just going to put a sine wave on here. So this is my source geometry. Okay, so it's reacting to the change. Now let me just write a little expression. What the heck?
Select it. And then like select it there.
Pardon me?
You have to like,
Sorry, I'm a bad mouser. So we can just say oh yeah, I think it'll work actually. Yeah, so they're all moving a little bit. So yeah, you can do that, but it has to be acting on the shape node. So it wouldn't. I don't think it would work if you animated the thing translating around. I think it has to be something that acts on the shape node. Although actually, I'm not quite sure. Would it work? They would move away from the particles if you animated the transform.
Tied to the particle
Yeah.
central point, right?
Let me just see. There's only one way to find out, really. Set a key. But this is tied to a certain point in time, so I don't know how this would work.
Well, that's it.
I've moved it away from the. Why did I do it so far? Well, anyway, it's. Yeah, let's see when it gets there. If it moves. This is your break, by the way. Just kidding. Almost there. Almost. Come on. Suspense.